Equipotential pool bonding, specifically NEC 680.26, and what does it take to pass your above ground pool bonding inspection. You want to remember to always check with your local AHJ authority having jurisdiction and your local and state adopted codes. References today are going to be taken from the 2023 NEC National Electric Code. What is pool bonding? Bonding means connected together. Grounding means connected to earth. By bonding different conductive surfaces of the pool together, you eliminate differences in voltage potential. So if all things are bonded together, so the pool water, the pump, if applicable, any equipment or a surface that is conductive is bonded together, then you won't have any differences of voltage potential in case there was a fault to ground. So let's just say that you had a utility fault to ground, and to make it easy, it was a 120 volt fault. Everything that was bonded together would be at 120 volts. So the pool water would be at 120, the pump, if applicable, would be at 120, any conductive surfaces and anything within 5 feet of the pool would be at 120 volts. So now if you're standing on that surface, that perimeter around the pool, which is bonded, and you touch someone in the pool, because there is no difference in voltage potential, there's not going to be any electricity flow. So it's going to eliminate or lower the risk of electrocution or shock because everything now is at the same potential. As I stated, references are going to be taken from the 2023 NEC. And this video is highlighting equipotential bonding as it applies to the 2023 TIA. So if you look at the slide I have up here, TIA 23.9 was issued after the 2023 NEC was published. And it has an impact on equipotential bonding, specifically how we look at perimeter bonding and what is allowed now in perimeter bonding as opposed to earlier cycles. If you're not familiar with what a TIA is, a tentative interim amendment, it's an amendment that the code panel comes up with based on safety concerns that they issue the TIA. If the TIA is adopted by your authority having jurisdiction, by your municipality that you're working in, then it is enforceable and you will have to follow it. Even though it may not be printed in the 2023 NEC copy that you have, if they adopt TIAs and they enforce them, then you'll have to follow it. So essentially what that TIA change was is it eliminated the number 8 perimeter bonding single conductor that was familiar more so in above ground pools, and it was also used in below ground pools as far as acting as a perimeter bond if you didn't have structural steel. So as we go through this, you'll understand it a little bit more, but essentially on above grounds, it was typically the number 8 that you used in the perimeter bonding, 18 to 24 inches from the inside wall of the pool. And that has pretty much been eliminated now in most circumstances. So instead, what you're going to see required is a 12-inch by 12-inch copper mesh grid or structural steel. Structural steel and below ground pools was pretty much familiar and common for any contractors that are installing in-ground pools and they're installing a concrete patio around that. The structural steel or the wire welded fabric that they put in the cement in order to make it more structurally sound, that was pretty familiar for in-ground use. The number 8 single copper conductor was sometimes being used in those situations or with patio stones. And again, that has now been eliminated. So they're looking for either that structural wire welded fabric or they're looking for a copper 12-inch by 12-inch square mesh that extends 3 feet out from the interior walls of the pool. And as we go through this, as you'll see in 680.26, there was one letter change that stated that if you're able to come in contact with swimmers, you weren't able to use that single number 8 copper conductor. Now 680 of the NEC is a comprehensive pool code. You should go to the entire code section for additional requirements for pool installations. In this short video, I'm not going to be able to give you everything. We're mostly talking about equipotential bonding and how to pass your pool bonding inspection. So you need to go to 680 to make sure that you're following and meeting all the other requirements in that code. And again, as I stated before, you want to always check with your local AHJ, your local state codes, your local amendments to make sure that you're meeting the requirements of 680 plus any local requirements. Okay, if you look at the slide I have up here, 680.1 is the scope article, and it basically says that all swimming pools, and then it gives you a list of the different types of pools: swimming, wading, therapeutic, and decorative pools. And this gets into fountains. It gets into a lot of things. So as I said, consult 680 for the entire code section, entire requirements. 680.7 is grounding and bonding in the pool code, and it talks about feeders and branch circuits. So any feeder or branch circuit installed in a corrosive environment or wet location, which obviously this is going to be a wet location, even a pump room is going to be a wet location, it has to contain an EGC, equipment grounding conductor, that is insulated copper, and it has to be sized in accordance with table 250-122, but it cannot be less than a 12 gauge wire. 680.7 talks about cord and plug connections. If it has a cord, it has to have an equipment grounding conductor. It can't be less than a number 12. And again, based on 251-22, the table, or at a minimum, a 12 gauge EGC, and it has to have a grounded plug on it. 687 of the NEC goes on to talk about the terminals, any kind of a terminal, any type of a lug that's being used around a pool equipment or something that's being buried. It has to be listed for wet. Damp locations has to be listed for burial. So any of the split bolts or the lugs that you're using to connect the perimeter bonding or any type of bonding has to be a listed lug. Any terminal that you're landing a conductor on has to be listed for wet. And again, if something's being buried, it has to be listed for direct burial. 680.8 goes on to tell us about cord and plug connected equipment. The maximum length of the cord is 3 feet. It has to have an equipment grounding conductor in it, again, a number 12 minimum. And then also it has to be a grounded type plug. 680.21 is about pool pumps or circulation motors. They have to be double insulated, and they have to have a way of grounding all the internal components. They may or may not be part of the equipotential bonding. It's something that you have to check with the manufacturer's recommendations, the manufacturer instructions that come with the pool pump. Typically, they're not part of the equipotential bonding, but there may be some conductive metal that's on the exterior of the motor, and there may be a lug on there. So again, you have to check with the manufacturer to see if they're required to be part of the equipotential bonding. And continuing in 680.21c, they have to be ground fault protected, GFCI protected, either by a breaker or by a receptacle. 680.22 goes on to talk about GFCI protection in the lighting and in receptacles. So you're required to have a general purpose receptacle not less than 6 feet from the inside wall of the pool and not more than 20 feet from the pool that's GFCI protected. It also cannot be more than 6 feet 6 inches above the floor or the platform of the pool. And as we just mentioned, 680.22 goes on to tell us that the circulation pump also has to be GFCI protected. It cannot be less than 6 feet to the inside wall of the pool or where the water begins. And this is often on inspections. When we go out on inspections, sometimes I believe electricians think it has to be exactly 6 feet. The code says it can't be any less than. So 6 feet, 1, 2, 3, 7 feet would be better than making it right on the mark, because you can't go less than the minimums. I always say that you at least have to make the minimum, and the minimum is 6 feet. Anything greater than that would be better. And any additional receptacles that you would have inside the boundaries of the pool, they can't be less than 6 feet to the inside edge of the pool, and they have to be GFCI protected. And then if you look at 680.22 number 4 in the slide I have up here, it talks about ground fault circuit interruption protection, but also special purpose ground fault circuit interrupter protection, so SPGFCI, and that's for higher voltage pools. We're mainly talking about above ground and 120 volt pumps. But anything that's 125 volt through 250 volts, 60 amps or less, and located within 20 feet of the inside wall of the pool, it has to have GFCI protection. And it has to comply with 680.5B or the special GFCI protection complying with 680.5C. And again, like I said, that's something 480 or higher voltages where you're going to see that SP GFCI protection requirement. So 680.26 continues to explain to us that we're just trying to reduce the voltage gradients. We're trying to reduce any kind of differences in voltage potential. And then it states it shall not be required to be extended or attached to remote panel boards, service equipment, or electrodes. So it's telling us that we're just trying to get all the conductive surfaces bonded together, but we're not going into the home, or we're not having to extend that to a panel board, unless it would be something metallic that is within that area, the 5-foot area of the pool requirement. So in 680.26B1, and if you look at the slide that I have up here, this is a concrete pool that's going to be poured. And you have all the structural metal, structural steel that is within the pool. And these are almost easier than above ground because now you're trying to figure out perimeter bonding. Typically these, you have all the structural steel wire tied together. You're going to have a number 8 that's connecting all the conductive surfaces to that grid. And then you're going to have that grid with jumpers coming out and in a minimum of 4 points connecting, again, structural steel that's usually going to be poured for some type of a slab that goes from the inside wall of the pool and extends at least 3 feet out. So these are pretty much easier and they're straightforward and haven't changed much. And you'll typically have jumpers coming out of here to pick up any type of perimeter bonding and to pick up anything else that would be required, like cups for ladders, diving boards, things like that. And I'll show you some pictures of that. So 680.26B1 talks about cast in place concrete pools, and because you're going to get a porous material, they consider those conductive. So you're going to have some type of a way of bonding that structure. And this is one way of it, structural steel. Now, if this structural steel was encapsulated, in order to achieve the equipotential bonding that's required, you would have to use the 12-inch by 12-inch copper grid over the encapsulated structural steel, following the contour of the pool, and then that would act as your bonding grid for the pool. And then you would do the same thing. You would have the jumpers going out to pick up any type of conductive metal to pick up the perimeter bond. So 680.26B2 goes on to just say what I explained, that it has to conform to the contour of the pool, be arranged in 12 by 12 inch pattern or a grid. And that's something that's you're going to purchase. This is something that you're not going to be putting together in the field. So it comes on a roll and it has to be secured within or under the pool, no more than 6 inches from the outer contour of the pool shell. So 680.26 goes on to tell us that the perimeter bond shall be considered to be from the inside wall of the pool to the outside, a minimum of 3 feet. So it has to extend from the inside wall to the outside, a minimum of 3 feet. And it shall include unpaved surfaces. And this is where it comes in with the above ground pools. So it's not just the paved surface. It's not just patio stones. It's unpaved surfaces too. And this is where we would normally put that number 8 in the grassy area, 18 to 24 inches away from the inside wall of the pool. That's where things have changed a little bit. So on this slide that I have up, 680.26B2 and all the B2B, C, and D, it's just saying that it has to meet these requirements. So again, go to your code and look at these different requirements. But I'm getting to where it talks about that number 8 single copper conductor. 680.26 goes on to talk about the perimeter surface and the 4 equal points of attachment. So on in-ground pools, on pools like I have up here that have a fiberglass shell, but then they have an aluminum collar around the pool, any conductive surface like that has to be bonded, and that's going to be bonded to the perimeter. So on these type pools, a minimum of 4 equally spaced parts. On your above ground, if you have structural steel, so you have structural legs and then they go up to a steel rim that goes around the entire pool. So you have to determine it. You have to look at what the manufacturer states. You have to look at, are there any conductive surfaces that can be touched? You have to determine if there is actually any structural steel or conductive metal or conductive surfaces that can be touched that need to be bonded. And those are the points that you would pick a minimum of 4 equal spots and come out to the perimeter bond and attach to that. And then that would attach to the other applicable equipment, whether it be pumps, heaters, the water, it's going to attach to those things. So all of it's going to be connected together as we talked about. And then this slide goes on to tell you that if the perimeter bonding is patio stones, if it's an unpaved surface, there still has to be bonding of the perimeter surface. It still has to be from the inside wall of the pool going outward 3 feet as a minimum. And it has to be structural steel. It has to be the wire welded fabric. So if you're going to pour a concrete pad around the pool, then the wire welded fabric is typically what we see, and you can bond to that. If you're not, if it's going to be patio stones, you're going to need typically copper, because you need something that's going to be listed to be buried. It isn't going to corrode under the patio stones. It isn't going to corrode in the grass. So that would be the 12 by 12 inch copper grid. It's a roll that you're going to roll out. And then that's what you're going to be attaching all of your equipotential bonding number 8s to. Okay, if you look at the slide I have up now, 680.26B2B1F. F is what changed for definitely for above ground pools. So F tells you, and for any type of a pool where they were trying to use the single number 8 copper conductor, they give you situations where you can use it. And essentially F is what is going to eliminate you from being able to use that single number 8 copper conductor. And under F, it tells you at the bottom of this slide, can be installed only in perimeter surfaces not intended to have direct access to swimmers in the pool. So essentially anywhere where you can stand on that perimeter surface, if you can touch a swimmer in the pool, you're not going to be able to use that number 8. So possibly there might be some areas of the pool where you wouldn't be able to stand and actually touch a swimmer in the pool, where this number 8 single copper conductor might be able to be used, maybe a landscaped area or something like that, where there isn't going to be any access for somebody standing there. But if you can stand in the perimeter area and touch somebody in the pool, you're no longer going to be able to use the single number 8 copper conductor as the perimeter bond. You're going to have to use the copper grid. And then this next slide, 680.26, goes on to tell us that it has to be buried within 4 to 6 inches below the finished grade. So the wire welded fabric or the copper grid could be within the pour, but if you're doing it on an unpaved surface or you're doing it under patio stones, you have to meet this requirement at the bottom of the slide here. 4 inches to 6 inches below the finished grade is the max that you can bury that grid. And then 680.26, 2B, 2D talks about bonded parts. And this is just what we've talked about a little bit as we've been going along. So the interconnection of all the bonded equipment or parts, applicable parts, motors, heaters, if it's something that's required to be bonded, the water bond, the skimmer bond, all that is now going to be connected with the number 8 to the perimeter grid. And that's how you connect all the surfaces together. And that's when you're going to be using that number 8 solid copper conductor to connect everything together. During the inspection, we're also going to look at other required bonded parts. So any type of lighting that would require bonding, there's listed low voltage lighting that's non-conductive that has to be listed. That's something that wouldn't require bonding. But again, you have to check with the manufacturer to determine whether or not that requires bonding. Any type of a bracket, any type of fittings for ladders or diving boards or things like that. Not typically what you see in above grounds, but you can. So any type of metallic fitting that's not over a 4-inch by 4-inch square and isn't penetrating more than an inch into the pool structure wouldn't require bonding. But when in doubt, if you have a conductive surface that you feel would be something someone would be able to touch that's on the pool, around the pool, it's something that more than likely would require bonding. And it's not something it's not going to hurt you to bond something that's on the pool, something that someone could come in contact with, to be sure that it's at the same voltage potential as everything else around the pool. The code goes on to tell us regarding other bonded parts that any type of electrical equipment that's within 5 feet that has a conductive surface would require bonding. Anything that's within 5 feet horizontally or 12 feet vertically from the pool. Double insulated motors, as I stated, typically they don't require bonding, but you have to check with the manufacturer. If there's a lug on it, that usually means there's some conductive metal and they want it bonded, but you have to check with the manufacturer. It will give you those instructions in the electrical schematic and the electrical specs. But you are still required to have the number 8 solid copper conductor there for future changeouts to a different pump that would require bonding. Any metal parts in the pool within 5 feet have to be bonded. So any fencing, anything that would be within 5 feet that's a metallic surface that someone could touch that is within 5 feet of the pool needs to be bonded. Okay, and we talked about pool water. Typically, the pool water bond is accomplished by some type of a skimmer bond. And this is one example that you can see in the slide. And it has to be a conductive surface, a minimum of 9 square inches that is continually in the water. So this skimmer bond is a listed bonding device. You might see other ones that are in the basket, but it has listed for pool bonding and for the water bond. Okay, so I created this slide to just give you a little bit of a recap. So if we look at the top of the slide, moving down to the right, so you need a general purpose receptacle not less than 6 feet from the inside wall of the pool and not more than 20 feet. The pump receptacle or the circulation receptacle cannot be less than 6 feet from the inside wall of the pool. And remember, on a lot of inspections, the electrician will make it exactly 6 feet or less than 6 feet. You cannot go less than the minimum. The minimum is not less than 6 feet from the inside wall of the pool. So don't make it less than that or make it right on the money. You're better off going a little bit more. Water bonding is required. So you want to have some type of a skimmer bond or some type of a bond that bonds the water, some type of a listed device for bonding the water. Pump bonding, if applicable. So if it's a double insulated, you have to check with the manufacturer specs because there may be a lug for some type of metal. The double insulated is typically protecting the inside components of the motor, so there isn't going to be a lug on it because it's going to be a poly type material outside, or it's going to be an insulated material on the outside of the motor. But you have to check with the manufacturer, check with the specs. There may be a lug on there because there's some type of a conductive metal on the outside of the motor that isn't being protected. So you might have to make it part of the equipotential bonding. You might have to bond to that lug if there is a lug there. So if available and if applicable, you're going to connect a minimum of 4 evenly spaced points on the pool to the grid. So on an above ground, you might have structural steel legs that are going up to a ring around the rim of the pool. So you're going to pick out a minimum of 4 of those evenly spaced, and you're going to connect it up to your perimeter grid. If there isn't any steel, but that's something you have to check with the manufacturer, you got to make sure that there aren't any conductive surfaces, because if there are, then you're going to need to connect them to the grid. Anything that somebody could come in contact with. Some pools are all poly now, so you might not have those 4 structural points. So then you're not going to connect the 4 points. You're just going to have the grid, the water bond, the pump if it's required, and other conductive surfaces around the pool, but you might not have anything on a completely poly pool. But that's something that you have to check with the manufacturer on. And lastly, the 12 by 12 inch grid has to extend for a minimum 3 feet beyond the inside walls of the pool. And it'll be buried a maximum of 4 to 6 inches below grade. Okay, so on an above ground pool inspection, we're going to look for that solid number 8 copper grid. We're going to verify that there's some type of water bond bonding the water. And we're going to check that if it's required that you bonded the pump. And also if there's any conductive surfaces on the pool or structural steel on the pool, that you bonded that. And we're going to verify all your split bolts, all your lugs, all of your components that you're using are listed for direct burial. All of your screws are listed for wet environments and direct burial. And that you use that number 8, that solid copper conductor, to connect all of the equipotential bonding components together. Okay, so I hope this video will help you pass your next equipotential bonding inspection for an above ground pool. Like the video, give me a thumbs up, and thanks for watching.